The Niagara Falls Water Treatment Plant has been operational for over 85 years and supplies over 80,000 residents in both Chippewa and Niagara Falls. This plant has a rated capacity of 145 megaliters per day. This plant uses 12% sodium hypochlorite as its primary source of disinfection. This chemical is applied to 3 different locations. The first being the raw water intake, the second being the UV discharge header, and the third being just after the reservoir as the water is making its way to the high lift pumps before it enters the distribution system. Raw water is extracted through a raw water main which is located 6 meters below the surface of the Welland River. This pipe is just over a meter in diameter and extends 139 meters towards the plant to provide the treatment plant with raw water. 2 traveling screen units are located in the raw water screen room. Each unit has a series of overlapping screen trays which prevents all large objects such as garbage, sticks, and fish from entering the plant and potentially damaging the equipment throughout the water treatment process. Once the water has been screened, it makes its way over to the low-lift suction wells. From the low-lift suction wells, one of the 5 low-lift pumps, which all vary in capacity and rating, will discharge the water at high speeds to a common pipe that then splits off into 2 additional pipes, which feeds each of the 2 flocculation tanks. Just slightly before the water makes its way to the flocculation tanks, it has to be injected with aluminum sulfate and quickly flash mixed with a large blade in a process known as coagulation. This process allows the particles to adhere and form larger and heavier settable particles called floc. After the flash mix, the next step in the treatment process is flocculation. Flocculation is a process used to form a heavier floc through a continued gentle mixing. Each of these cells contains small holes to allow passage of water from one chamber to the other. In plant 2, water enters the bottom of cell 1, raises and overflows into cell 2, then descends and enters the bottom of cell 3. After that, it raises over and overflows into cell 4. The water then descends and enters the bottom of cell 5. And lastly, raising and overflowing into cell 6, and then exits the cell and enters the sedimentation. Sedimentation is a process of removing settable materials. This is done by decreasing the flow velocity in the settling basins to lessen the ability of water to hold particles in suspension. The main function of this basin is to remove as much of the suspended particles as possible to reduce the risk of clogging the filters and increasing the runtime between backwashes. This plant has 12 dual media gravity filters, which have a total filtering capacity of 145 megaliters per day. Water above the filter media forces water downward through the filter, and suspended matter such as silt, clay, algae, and pin flock are removed by the media. This process consists of 5 Trojan Swift ultraviolet reactors, each rated at an approximate 30 megaliters per day. Each reactor consists of 4 9.4 kilowatt medium pressure ultraviolet lamps, which when running are powerful enough to inactivate pathogens, making them unable to replicate and therefore harmless to humans. This is the stage of the process where the chlorine disinfectant is added an additional time before the water heads to the reservoir holding tank. This is a 14 million liter holding tank that provides water with a sufficient amount of time to react with the chlorine and inactivate the pathogens. This period of time is known as chlorine contact time. In the final stage of the water treatment process, the now fresh water is sent out to the distribution system by the high lift pumping station. The high lift pumping station is used to supply water to the distribution system with enough sufficient flow and pressure to meet all the service requirements. This pumping station is made up of 5 dual suction centrifuge split case pumps, which each differ in size, so they all vary in speed and capacity. Now that the water treatment process is complete, you are left with nothing but clean, healthy, and safe drinking water for all.